and welcome to another episode of REDtalks.live. I am your host, Nathan Pierce. REDtalks.live is your home of ranting engineers and DevOps. And today's topic in episode 48, I could be wrong, I think it's 48, is API monitoring and visibility and that whole general theme. And I'm really excited about this topic. I'm very interested in it because if you look at a lot of the visibility and monitoring solutions out there, they're very much oriented around your traditional application. That's the web application. It's a web server and a middle tier, and that's a very busy market with a lot of solutions in it. But everything's machine to machine these days, or iPhone app to machine, and it's all API driven, and we're in an API centric and an API driven world. So who's starting to provide that visibility and link it all together and end to end kind of solutions for us and make things, bring clarity to the API market? And that's why today I have as our guest, I have Rob Dickinson from Resurface. Rob is the founder and CEO of Resurface. Rob, please introduce yourself.
Hi, thank you so much for having me. It's a pleasure to be on. Big fan.
So, Rob, tell us, how did you get started? What got you up one day to think, I'm going to go solve this problem?
Yeah, so my background is in web monitoring, and I helped architect a company called Zapfire back in the day, and we competed with Tealeaf, who was kind of the big vendor in this space. And there were other vendors, of course, but basically what we were all doing was we were putting packet sniffers on your network and monitoring the network in an attempt to gain visibility into your applications, how your applications were performing, whether they were doing the right things, whether they were responsive, whether the user outcomes were as expected. And as you said, they're really, the world is very different from when we started back then. So we had kind of a great ride. We competed against Tealeaf for about a decade. We ended up being part of Dell in the end, and we had some great customers. But as you said, the world has completely shifted. And it's shifted from being a web-centric world to an API-centric world, and obviously that's a very disruptive shift. And then the other thing is it's shifted from a world where you control the network to a world where you're running in the cloud, and you really have limited control over your infrastructure. And so really those two things more or less killed off those traditional solutions, except for the ones that are really security focused, where you really have to be at the network level. But all the big vendors, Tealeaf sold out to IBM to kind of consolidate a growing share of a shrinking market. And I was really frustrated. So I left Dell a few years ago, and I started thinking on my own. And I'm a startup guy, and so I fell into another startup right away, and we were running on Heroku, on AWS. And I was so frustrated. We were having these problems come up. Customers were saying, I couldn't do this, I couldn't do that. Here's the error message I got, or here's what time it was that I was on the site and I was trying to do this. And we also had mobile apps that were trying to use these APIs that we had exposed, and that created a whole nother set of conditions that really we didn't have visibility into. And I was just so frustrated because the whole time I'm sitting there going, wow, if I controlled the network, I could just throw a packet sniffer on there and I would know what was going on the same way that we would have for the last decade with the technology that we've built. But you simply couldn't apply it in the cloud. And so that's really kind of the seed idea of Resurface, and really what we've been exploring is that it's not a web-oriented world anymore. These web monitoring techniques, you need an analog of that in the API context. But you can't do exactly what you were doing before, and the technology that you had before doesn't apply exactly. And then the bigger thing, as I keep harping on, is that we really don't have control over the network anymore. We're trying to do everything in the cloud, in user space, as part of the application. We want to be DevOps friendly, and there's all kinds of challenges in that. Even if you even if you say, well, because of how I'm running my APIs, I actually do have some control over the network. It's still at odds with being really DevOps friendly. It's easy to poke at. All you have to ask is, well, so how do you handle a canary deployment? How do you tell your sniffer, this subset of systems over here is going to be running one old version, and this stuff over here is going to be running new versions. It's just that kind of stuff just doesn't really play out in the modern world.
I appreciate your overview there, Rob. And the one thing I always refer back to when I look at tooling and how it's being broken these days is now you look at the way distributed applications are designed and implemented, or even applications that run on mobile devices. They might use a service at Auth0 for identity, and then they might talk off to a data stream somewhere else. There's no, like, where's the packet sniffer go in that environment?
Exactly. And I think the other thing is that a lot of the value proposition behind a packet sniffer was that it could be done orthogonally. You wouldn't have to involve the development team. It could be done by the operations team long after the application development was done. Of course, we live in a world now where our application development is never done. We're pushing builds every 5 minutes. So it just the packet sniffers just really don't end up giving you what you think you were getting. But the value that people saw was that you could just kind of slap it on there without really thinking about it from when you were actually building the application. And unfortunately, you have to then shift your perspective. You really have to engage with the development team. You really have to deliver libraries as the solution. And I think just a lot of the vendors that were already out there they were not built for that at all. They were really built to talk to network people and ops people. And as soon as you start talking, well, instead of throwing a packet sniffer on, we're going to develop a Java library that effectively does the same thing. And then we'll do it again for Node.js, and we'll do it again for Go, and we'll do it again for this and again for that. That really was not the kind of IP that I think any of those vendors really had. And to be fair, those packet sniffers are really, really hard to build. I mean, it is millions and millions of dollars to build a reliable packet sniffer. They're very complex machines themselves. So
and the amount of abstraction, so that was an easier time, the packet sniffer kind of era, when services and applications were often identified by TCP socket or a UDP socket. You could actually be like, okay, well, I know things from here to there is that user's session. And then we had the era of like HTTP-based applications where it was all about like a cookie or something. And it was like, well, hang on, now my packet sniffer can't operate down at this easy layer 4 where I just have to map a socket and look at everything inside of that. Well, now I've got to actually look inside of the socket and specifically identify a layer 7 attribute. And then you get into like now today's problems where it's all microservices. So it's not even a single point I'm talking to, it's many, and they're ephemeral. So how could I possibly be tracing all of that inside of a packet sniffer type architecture? So it becomes extremely difficult. The abstraction layers are going higher and higher, not just to the communication, the TCP or UDP level, but even to the destination you're talking to. Maybe that is a serverless architecture. Where do I run it now? Like, it's ephemeral. So like, there's new problems to work around. Like the old tooling just doesn't work unless someone's going to let me march into the cloud provider and plug something into a rack that I feel like being on, which I can't see happening.
Yeah, so I personally, I think it makes a lot more sense if we start to talk about our monitoring services and our other kind of secondary services as just other microservices that we're calling. The average API is calling out to between 50 and 100 microservices, depending on the vendor that you're talking to. That order of scale is not unusual at all. So what's one more to do performance monitoring, or what's one more to do usage logging, or what's one more to do error logging? We're kind of used to having to hand all this data off to a third party and use a separate solution for doing that. But at the same time, internally, we're rebuilding all of our architectures for this highly distributed microservices idea. So we really think like that's really the proper place for monitoring. Is you're already calling a bunch of other microservices, and really your monitoring services should fit that same profile. And the other thing that's really exciting about doing that is, as you alluded to, the complexity in actually recreating what you saw on the network to understand what that means to the application is pretty horrific, right? You have to reassemble a lot of data. You know, even though you started off with this idea that somehow the sniffer is going to be an orthogonal thing and you can just plug it in on the network and kind of monitor anything, to actually make sense of that data, you have to do a lot of reconstruction of the data that you're seeing. And so let's take a really simple example like sessionizing. For sessionizing, you're going to have to tell your sniffer kind of where that session variable lives. Is it in a cookie? What's the name of the cookie? Are there multiple cookies? Does one come first? Is there precedence? Is it broken up by subdomains? Or is that session information buried in the page content somewhere or in some other way of transport? These are all real cases that you're going to see pretty much right away. And so you have to be able to describe all of that, again, in a way that you can evolve it in lockstep as the application changes. It's a huge problem to have to tackle. If you're delivering instrumentation, though, your instrumentation is already part of the application. So in our case, we don't have to actually ever reconstruct what the sessionizing is or know anything about what the sessionizing rules are. We simply have our instrumentation ask the application at runtime, hey, what's the current session ID? Do I have one? Don't create one because I don't want to actually mess with the sessionizing. But if there is one active, then you can just read it, and it's literally 2 lines of code to do that. So being inside the application actually opens up inspections of all kinds of data that is really critical to the application state. And some of it never goes over the network, right? Some of it is literally the private application state. You can now interrogate that from inside the application, rather than hoping to see it go across the wire at some point, and then hoping that you can grab it and keep it until when you actually need it later. It's very, very difficult, the sniffer modeling.
Yeah, and so this model you're talking about, that you're working in, like actually getting the data directly out of the application itself and getting that information that you needed and streaming it to your service, that actually lends itself to environments like microservice architectures, where a lot of the communication is actually microservice to microservice and service tracing and those kind of things, like actually getting and understanding some visibility of that. I had Niraj Potter, quick shout out to Niraj from Aspen Mesh on, who was telling me about a problem he was having in AWS, where AWS was stripping out the headers they were inserting between each hop, which made it impossible to work out where things were going. And they had to do quite a lot of work to kind of understand, how can I do this? I need to step in after it strips out and reinsert again and then strip it out again. And it was just this ridiculous game within architecture. So visibility became quite difficult when working on certain platforms. You're almost fighting against the architecture underneath to bring some sanity. And that's because in those environments, people weren't actually doing it from within the application. They were trying to bring their visibility from the architecture that the application was running on, which is what you were just describing, if I understood it correctly.
Yeah, and the other solution that's very popular, again, that's kind of been translated from the web monitoring world, is the idea of synthetic monitoring. So that would be something like a run scope is doing, or even Postman has facilities for this. And so the idea is you set up a script and you're going to monitor those APIs from the outside. And so now I don't need to control the network. I don't need to put a packet sniffer on the network. Instead, I'll use an outside system to validate what I'm doing. And that really did come from the web monitoring world. Folks like Keynote were really doing that for websites, a million years ago. But there's analogs of that today for API monitoring, and they are very powerful and they are very useful, but their visibility is limited because obviously it itself is like a canary script. It can only tell you if that predefined behavior is working or not. it really can't tell you about all of the different behaviors that are actually going on in production. And it's really interesting because the synthetic monitors, they actually position around this idea of telling you that everything is okay. But in some cases, that can really be a false sense of security. A lot of the problems that we tend to want to track down with something like usage logging or deep API monitoring are problems that aren't happening every single time. It's relatively easy to detect some kind of big outage or some kind of big failure. It's really, really hard to detect things that may seemingly be okay, but really from the perspective of the users are definitely not okay. So here's a good example. One of the retailers that we were working with a few years ago in my previous life, they pushed out some new code into their site and their back end, and they had a bug where if there was a zip code that had a trailing 0, it would strip off the trailing 0. It would think that the zip code was only 4 digits, and it would give the user back this error message saying, "You entered an invalid zip code, please try again." And so people would get caught in this loop where they'd enter their zip code, it would get rejected, it would throw them back on the same page, they'd enter it again, they'd get rejected, they'd get the same error message, and they wouldn't be able to get any further in the checkout process. And what was really hard to find is that there were no exceptions being thrown, there were no performance problems that you could trap and say, oh, I've got a problem. There were no alarms going off, right? There were no 404s being thrown or 500s being thrown. It seems like everything is okay, but it absolutely wasn't. So what we were able to identify, we were able to actually find the problem. We were then able, with the data that we had, we were then able to find out who was affected by that, who were the actual users that were in that infinite loop. And then we could go back to those users and say, here's the list of accounts that were affected by that. Hand that off to the business then and say, these are the people that you need to go back to and offer a coupon to come back and finish their order because you screwed up and that hurts your brand. And so now it's not just being able to detect those problems, but actually having the data that you need to recover from those problems.
That's interesting. And I actually have a personal experience from that kind of thing as well, where as someone who's lived in a few different countries, sometimes I am online and filing things in a remote country of previous residence. Maybe I'm doing my online tax return. And when I have to put in something like a zip code or a postal code, everybody codes in their expected, it's almost like a regex level, like it must conform to this. Every country has a different format. And I'm always that person who has to get up really early because of a time zone issue and walk someone through everything that's going on. And they're like, oh, well, we only thought people in our country would ever use this. And this never turns up as something that they see as an error or troubleshooting. It's a user experience thing that, I mean, maybe we could talk all about better UI kind of validation of field inputs, but there are these tiny use cases that, yeah, don't turn up in their testing, because when they're using their tooling to test it in synthetic testing, they would never put in an invalid, well, a valid one, but not valid to them.
Yeah, exactly. It is so difficult to predict user behavior, whether it's on a website or an API or mobile app or whatever. It's just like any kind of creative work where the person that comes to it, you know, they always overlay something unique and something that's unexpected. And I think it's true of every discipline, but it's certainly true in software engineering. And unfortunately, I think that problem is only getting worse. I mean, the more we go towards smaller and smaller and smaller microservices, the more our connected paths go up. Effectively, the more inputs and outputs you have to these systems, and the harder it is to get that visibility. And just tracing through it all is not the answer either. You need to end up with data that's actionable in the end, which is very difficult. So it's this balance of how do you gather enough data to give the visibility that you want to, and then to also respect security and privacy. Because in these cases that we're talking about, a lot of these that are really interesting are the ones where we also have a lot of personally identifiable information. And we really feel that's another big line of demarcation between what we're trying to do with Resurface and what we see these other solutions doing. If you're doing a synthetic monitoring solution, it's a third-party solution, but there really is no PII because you're defining what the predefined script is. You're not actually ever going to have a chance where you leak credit card numbers or something to that vendor. And most of the APM solutions, error logging solutions, in fact, pretty much all of the monitoring solutions that I can think of, they really want you to get rid of that PII. They don't want to be your data processor, especially under GDPR and where privacy is going. Being someone's third-party data processor is really becoming a huge challenge. So we think the way to do that is to add an additional kind of logging solution to these others. So we don't want to displace your APM solution. We don't want to displace your synthetic monitoring solution. What we want to do is provide an additional API monitoring solution that's capable of gathering that PII and providing that visibility that you need to do that. And there's really two components that you need to do that. You need the instrumentation that plugs in that now can interrogate the application the way that we were talking about. And the second part is you need a first-party database for that data to reside in. So this is the other, I think, big line of demarcation that we see, is that nobody wants to take your PII, and we're included in that. We actually think the better way to do that is to enable customers to run their own first-party databases. And so now really the trade-off is, are you going to build something custom as part of your API to do that level of visibility, or would you prefer to use a system that keeps it first-party, but you don't have to build everything as more cost-efficient? Okay. What we hear from a lot of our customers is that we've talked to in the past is they're running synthetic monitors, and that's great. It gives you necessary visibility into your infrastructure and into your operations. That's really important. And then what they'll say is, yeah, we're doing stuff with synthetic monitoring, but then when we have our user checkout, that's really important. We've got a lot of revenue that depends on that. So we build all this stuff into our API or into our application to actually give that necessary visibility. We'll go to the development team and we'll say, hey, you need to keep track of the user sessions so that if somebody abandons, we can send them a coupon to come back. And the development team goes, oh, how are we going to do that? It's a huge volume of data to capture. We have to respect security. We have to meet PCI requirements. We have to meet this requirement and encryption at rest and this and that and this and that. And then with privacy, are we getting consent the right way? Do we have the right kind of controls on our PII? Are we masking the right kind of things? There's a huge number of problems that end up having to be solved. And right now, there really aren't third-party solutions that want to do that. There is this firewall that PII has to stay in-house, and you really can't use a lot of outside solutions to do that. So we don't want to be your data processor either, but we want to provide those tools to make that kind of data collection easy and responsible and much more cost-effective than having to build it yourself. So the instrumentation is definitely a first step, but the second step is really, and what we've been working on, it's not on the website yet, but this is kind of the next phase for us, is this idea of this first-party backend to complete that story.
That's cool. And for those who want to take a look at what is on the website already to see some data, it's resurface.io. And you've actually got some tools you've made available via GitHub as well, some open source kind of content out there. So next up is this kind of first-party database for handling that kind of sensitive data, not having to bring it off premises and create all sorts of governance kind of headaches for both you and your customer moving forward. So let's talk a little bit then about what we might do with this data. So I mean, there's this huge problem of collecting it. And anyone can just turn logging on a server. That was the old world. You'd turn the logging on and you'd say, you know what, Apache log these fields to here, or maybe like Nginx or whatever it is that you're using in your front end. And that's what people did. And they had some middleware logging that was maybe, you know, some huge RAM-hungry Java virtual machines that were just dumping out session-level stuff, and you would manually kind of map some of that together to try and work out where an error was. But in the modern day, we don't have that luxury. That's not what's going on. So you're able to, with your solution, you're giving an ability where we can start mapping some of these things together. But then, what should we be doing with that? I mean, I guess I can then apply some clever things like some machine learning heuristics to that. Talk a little bit about this. I mean, what are your thoughts in that kind of area?
Yeah, so in terms of the use cases, I think the ones that are easiest to understand at first are kind of ones that you'd have in a steady state condition. You know, I've got a user checkout where I'm taking credit cards and things like that. It's very important. It's obviously, if that goes wrong, I'm going to lose money. And I think that's an easy metaphor for people to understand. There's an ongoing need for that kind of visibility, and if you don't have that kind of visibility, you're going to get in trouble. And your business folks are not going to be okay with the DevOps team just saying, "Oh yeah, we fixed the problem. Our bad. It won't happen again." Right? Prove to me that it won't happen again. How are you going to detect those things? So I think I think those cases are easier to understand because they're more of steady state and ongoing. But what we're particularly interested in is where you'd use this more on an ad hoc basis. Where I get really excited is when I start to think about, can I do this on any area of my application, or can I do this on any area of my API where I need that visibility, and make that more as a just-in-time kind of decision. Now we're really starting to open a big gap between building something yourself, being able to apply something cost effectively very quickly. So let's say I hear about a new kind of problem going on, and you always hear about things that are going on before, and you maybe don't have a way of zeroing in on it yet. You don't know exactly what's going on, but you hear something through the grapevine. If I can put down an experiment to do that, if I can gain some visibility and run an experiment, well, is it really this? Is it really what the theory is? Or can I disprove this? Can I shed some light on that right away? If I can do that without having to go back to my development team and have them build something into the application to give me that visibility, I think that's very interesting, because I'm going to have new problems next week that I may not be anticipating the needs of my visibility in order to solve those. This is really, if you knew where to look, you would know where the problem was. And that's such a big part of the overall headache of dealing with something like this in production. And I think, you mentioned machine learning. I think machine learning is a very good example of this. You usually don't want to gather data on an indefinite basis to feed into a machine learning system. What you usually want to do is you usually want to say, I want to do this kind of recommendation engine, or I want to do this kind of machine learning system. You obviously need good data to train that system. Those systems are only ever going to be as good as the data that you feed into them to make sense of. So again, it's this problem of, do you go back to your development team and say, hey, I somehow need to get this user data so that I can train this new system? And your development team laughs at you and they say, yeah, but it'll take 6 months. And by the time we get it done, the company, the business will have moved on to something else. I think that's another good example. If you can cut that time to get the visibility down, to where you can stand up a new study this week, do a new study next week, do a new study next month. Now it's a much more exciting world. I think if you can do this more on an ad hoc basis. So that's, I think, whether it's machine learning or whether it's troubleshooting or whether it's trying to understand user behavior, it's being able to fit those visibility needs into your stack easily as you need it, and then change that over time as your needs change. That's a very exciting world, I think, and that's beyond anything we would have ever been able to do with sniffers or synthetics on their own.
That's really interesting. I like what you're out there to solve here, and I'm really interested in following kind of your developments and some of the use cases. Thanks for sharing those examples you just provided. One last question, we're kind of running out of time here for the episode. Where are you guys in your journey? Like you mentioned, you're a startup guy. How far along are you? When can people kind of see what's going on? Should they be reaching out to you right now?
Absolutely. We'd love to hear from anybody that wants to try out our tech. All of our instrumentation is already available. We support Java, Node.js, and Ruby at the moment. Multiple frameworks for each of those languages. That's all on GitHub, and we're committed to all that being open source. That becomes part of your application, and so you need to be able to see that. And so that's available now. We also have some free demo environments that are available. We have a live demo, but then we also have a Docker container that's a demo environment, and we have some YouTube videos that show you how to wire that stuff together. It's really easy. Basically, you need a URL where the data is going to go, and you plug that URL into the instrumentation, and that's basically it. So you can see how that whole experience works today, and we've already had a few people evaluate the instrumentation and try it out, and we've had really good results with that. And then we're taking beta applications now for our initial backend database. So we are accepting beta customers now. And we'd love to work with anybody that would like to take that and kick the tires.
That's really cool. I'll make sure I get some links off of you to those things where people can take a look at it, and I'll include them in the blog, which this video gets embedded into, so that anyone who is interested in API monitoring and visibility, they can start working on getting their head around it, at least planning what they might be doing for that next. So thanks very much for coming along today, Rob. This is Rob Dickinson, you've been listening to from Resurface.io. Great episode, Rob. Thanks for coming along.
Thanks again for having me. This was a blast.
Awesome, and we'll speak to you again hopefully in the future about any updates and how you go with that first-party database solution that you're developing now as well. So this has been another episode of REDtalks.live, episode number 48. I've been your host, Nathan Pierce. Thanks for listening.